Welcome back. This is an Aleks teaching video on deducing the allowed quantum numbers of an atomic electron. There are 4 quantum numbers that perfectly describe the address of every single electron in any element you want to look at. The first one is the principal quantum number. And the principal quantum number is n, and it is equal to the period on the periodic table of the electron. Okay, so the first period, the first row, would be n equals 1. That would be hydrogen, helium. N equals 2, lithium, etc. And n equals 3. Each subsequent row would have a new n number. So n equals 1, n equals 2, n equals 3. So n could equal 1, 2, 3, so on. We have up to row 7, up to period 7 on the periodic table currently. Okay. The second quantum number, okay, is the angular momentum quantum number. The angular momentum quantum number is L. Let's do it as a shaped L. Okay. And there are going to be 4. 0, 1, 2, and 3. And it tells you what your subshells are. So if L equals 0, you have an S subshell, and L equals 1, you have a P, L equals 2, you have a D, L equals 3, you have an F. Okay. Your third one is your magnetic quantum number. Magnetic quantum number tells you, which is m sub L, and it's how many orbitals you have. So it's 2L plus 1. So let's say your L is 0, then it's 2 times 0 is 0 plus 1. There's 1 orbital. That means there's 1 orbital in the S subshell. If your L is 1, that's 2 times 1 plus 1 is 3. There are 3 orbitals in the P subshell. So the S subshell, remember, only has 2 in it. So there are 2 electrons in that orbital, in the S. The P have 6 electrons. That means this is 1 orbital, that's an orbital, that's an orbital. Okay, so it is 1 times 2 plus 1. Then this would be 5 orbitals. Okay, so this would be S, P, 5 orbitals, which is 10 electrons, and then F is 7 orbitals, which is 14 electrons. Okay, so this tells you how many orbitals you have, that subshell number. The last one is the spin quantum number, m sub S. Okay, and it'll either be going in one direction or going in the other direction. Okay, so this is 2 electrons allowed in one orbital, and one is spinning in one direction, the other is spinning in the other direction. So these 4 numbers will give you a perfect address of where any particular electron is at any time that you want to consider. All right, so this question is, what is the smallest possible principal quantum number N for an F electron? Well, an F electron, okay, an F electron has 3 is a L equals 3. Well, when do you have L equals 3? In N equals 1, you have an S subshell. In N equals 2, you have a P. N equals 3, you have a D. N equals 4, you have an F. That means the first time that you're going to see an F subshell is in row 4 or period 4. So that is going to be principal quantum number N equals 4. All right? Hope that helps you.